In this video, we're going to look at how we can solve equations that have either 0, 1, or an infinite number of solutions. But we're not going to use the traditional solve for x approach. We're going to use a triple number line. Let's check it out. Here we have three number lines, all parallel to each other, and on the top number line, we have our variable x, represented by this point. And I can drag this point to the left or right, and as I do, I am varying the variable, and we see the location of point x on our number line reported in the top left corner. Right now it's equal to negative 1.9. Now, sitting below the value of x are two expressions. And these expressions are the left and right side of the equation I would like to solve. So the equation here is 2 times parentheses x plus 1 minus 6 is equal to 3 times parentheses x minus 1. And as I drag x, we see the values of the left and right side of our equation are reported. So we know here that this value of x of negative 1.9 is not a solution to our equation because the left and right side of the equation have different values. And notice that we have not just the numerical values reported, but we have these locations on the number lines. So here on this second number line, we have a pointer, and this pointer is indicating the value of this left side of our equation, negative 7.8. And on the third number line, we have a pointer that's indicating the value of the right side of our equation, negative 8.7. So to find a solution to this equation, we need to drag point x and look for a spot where these two pointers line up. And that occurs, right here. At x equals negative 1, both the left and right side of my equation are equal to negative 6. So by dragging point x and looking at the behavior of the pointers on the second and third number line, we can solve this equation without using our traditional algebraic approach. Quite nifty. Now on page 2, we have a different equation, and we can see the left and right side of that equation here. And once again, we'd like to find the value of x that creates a situation where these pointers line up, one above the other. And look, it seems like before we've even dragged point x, we've already found the solution. When x is equal to 0, both the left and right sides of our equation are equal to negative 8. Well, let's try dragging x and see what happens elsewhere. And notice something kind of interesting. No matter where I drag x, both the left and right side are always equal. These two pointers are moving in lockstep, one always directly above the other. So it appears that there are an infinite number of solutions. And if I'd like to expand the domain on which I'm dragging x to check out some more values, I'll press Show Unit Point, and then drag this point at 1 closer to 0. And now when I drag point x over this wider domain, we see that, sure enough, the two values, the left and right side of our equation, are always equal, and these pointers sit one directly above the other. On to example 3. Here we have our new equation, the left and the right side of it. And as I drag point x, well, once again, it seems that these pointers are moving in lockstep at the same speed, but now the pointer on the second number line is always one to the right of the pointer on the third number line. Never shall these two meet. Here we have an example then of an equation that has no solutions. And we see that visually by the behavior of these pointers on the number lines. On the last page of our web sketch, we allow you to create your own equations. So we start with defaults of 2x and 3x, and if you double tap on either, it will open Web Sketchpad's calculator and you can change the expression. For example, I can change this from 2x to 2x plus maybe 4 times x, and to enter x into this expression, I tap directly on the x in my sketch. So 2x plus 4x minus 3, and then I tap OK.